Alright fellas, what we're having a look at today is the idea of an increasing and a decreasing function. We already know that the derivative of some function tells us about the gradient. Now what we can now add to that is if I have some function fx equals 3x squared plus 6x, let's say. Now I know that we use our notation. I say, well, my first derivative is f dash x. Well, if I say my first derivative there is positive, it means that I have a positive gradient. So I have some slope that is positive. What we say is that that function is for those values, for the values where my first derivative is positive, I call the function increasing. Okay, we say that's an increasing function for some value of x there. Now, we could probably go and look and say if I picked an x value of 20, means my first derivative is going to be positive. We'll look at the actual example shortly, but we could see that the gradient would be positive there. Similarly, if I went and said my first derivative is negative, it means I have a negative gradient, and we call that, no surprise, that's a decreasing function. Okay, so we say for those values, the function is decreasing. And then in the same way, if f dash x is equal to 0, what we actually say is that is stationary. Okay, that's a stationary point, and normally, not always, but normally that represents a turn on our curve. So it's the vertex of a parabola or alike for a cubic or quartic, but there are cases where that's not true, and we'll look at those in this topic, but that's typically a turning point if our first derivative is 0. So if we look at our example here, let's see if we can find the first derivative of this to start with. So let's go, for starters, f dash x equals 3, sorry, that's not 3, that's a 6. 6x plus 6, now that's using our standard differentiation where we multiply the coefficient and the exponent and decrease the exponent by 1. Of course, this 6x has a power of 1. That's from last term, nothing new there. And if we look at our example here, what we're really being asked to find is, where is the gradient positive? So we just found an expression for our first derivative, which was 6x plus 6. Now what we want to do is actually find where that's positive. So all we need to do is go set up an inequality. 6x plus 6 is greater than 0. Or I'm going to say 6x is greater than negative 6, or x is greater than negative 1. So for any value bigger than negative 1, my function here is increasing. So that means for any value bigger than negative 1, I'm going to have a positive gradient on that curve. Now we could draw a very quick sketch of this, and what would we have? Well, I can factor that. That's 3x outside of x plus 2. So now that's got roots at 0 and negative 2. Okay, and that's my parabola. Now that's the graph y equals 3x squared plus 6x. We could go work out where that vertex is. But in fact, we don't need to, because what we'll see is that vertex is actually at negative 1. We could find the y value as well. What is it? Negative 1 squared is 1. 3 minus 6, that's minus 3. That vertex there. But what we notice is it's a turning point on our curve, but it's also where our gradient changes as well. It's where all these gradients here, everything over here is negative, becoming less negative, and then after this point here, these gradients become positive, and will keep becoming very positive as we keep moving further to the right on our curve, and increasingly negative as we move further left on our curve as well. So that's, if I have x is greater than negative 1, it's increasing. As a little aside, if x is less than negative 1, that's where my function is decreasing. And if x is equal to negative 1, that's where we say it's a stationary point. And in this case, it is a turn. We do a lot more of this sort of stuff as the topic progresses, but for now, that's what we need to be able to understand. Okay, if we have a look at another example here, for what values of x is the function fx equals x cubed plus 4x squared minus 3x plus 2 increasing? So straight away, let's go find out derivative. It's f dash x equals 3x squared plus 8x minus 3. Okay, so we're increasing. Okay, we're looking for where it's increasing, which means that I need the first derivative to be negative. I need negative gradients I need positive gradients for any tangent that I draw. Now obviously this is a cubic. This is the typical shape of a cubic. So we've got some points here where the gradient is positive. Over here the gradient's positive, then in the middle it's negative, and then out here it's positive. We've got a couple of turns as well. So this one isn't straightforward in the sense that the last one was, but we approach it the exact same way. So I'm going to go use my first derivative there, and I'm going to say 3x squared plus 8x minus 3 is greater than 0. Now that's an inequality, a quadratic inequality, so I need to factor it. So I'm going to have 3x and x. Now I'll let you factorise this. If you'd like to pause it now and try to factorise it yourself, please feel free, but I am going to proceed. Well, I noticed that it isn't all divisible by 3, so that means my 1's going to have to go here, and that's my 3. What we end up with is this is my positive term, and that's my negative 1. So now what I'm going to sketch here, I'm going to draw a little sketch. This is what we do for a quadratic inequality. I'm going to sketch the gradient function. Okay, now this is not my original function. I'm not sketching my cubic, I'm sketching my gradient function, which is this guy. So that has roots at a third and negative 3. It's concave up. So where is this black line here, this black curve above the x-axis, above this one here? Well, I hope you can see it's out this way and it's out this way. So my solutions are it's increasing if x is less than minus 3 or x is greater than a third. And again, what I've sketched there is the gradient function. That's my sketch of the gradient function. I'm actually not going to draw a sketch of the actual function, but you'll see this answer we found here kind of makes sense given this little rough sketch of a cubic that I did before. It's got positive gradients out this way and this way. Obviously the numbers are wrong, but what you'll see is that as x gets really, really big and positive or big and negative, the gradient's positive, but in between there it's negative. We could go and set this up and find where it's decreasing. It would be between a third and minus 3, and obviously at minus 3 and a third, which would be these 2 points here, it's stationary. And we'll look more at stationary points in the coming weeks. Theories on island. I hope this helps.